To create the model, we start with part. In here, we select 3D deformable shell planar, and the approximate size should be 1. And then we put the first point on the center, and the second one, it should be 0.2 and 0.5. Here it is. And after that, we gonna fix these points. We don't want to change them. Okay. Then we draw a line from here to here, and another one here. We draw a circle, another one for here, and then we assign the dimension. 0.1 for here, 0.1 for here as well. The radius should be 0.05. This one 0.025. Okay, and then we draw a line from here to this line, here to this line, here to this line, and another one here to here. And then we can trim the sketch. Okay, and now our part is ready. The next step is for property. For property, we need to assign density 7800, elastic modulus 200, E9, Poisson is 0.3. For plastic part, 100 is 6, 0, and the next one is 206, 0.1. Then we can go to section, we select the shell homogeneous, and in here we assign 0.01. 5 integration point is enough for here. And now we can assign the property to our part. Next step, we need to define a step, static step, NLG it's better to be on. 100 is fine, 0.1 for initials, and minimum and maximum is fine. And in here we need to input the par. In load, we need to assign a load concentrated force for this point in x direction. Here I need to assign 3500, and we need to constrain this part, this line, and after that we need to mesh it. For mesh part, we need to assign a fine mesh. It doesn't matter a lot, but it's better to have a fine mesh. Here it is. It's not the best mesh that we can do, but it's fine for now. In here we can assign the element formulation. Reduce integration, no, we don't want it. Its shell is fine. Yep, everything's fine. Before doing anything, we need to set directory file. I set the directory file. After that, I need to save it. Call it Python. And in here, I create a job. Job 1 is fine. Write input. And now we submit. As you can see, the job is completed. Now we can see the results. Here it is. It's almost in the plastic region in some parts. And now we need to develop a code for Python so we can have parametric static. For this purpose, we need to go to our directory here. Then we copy this part and say paste it in here, and we change the name and the extension, and we paste it. Sorry. Then we open it with Notepad++ or Plato, it doesn't matter. We'll look for submit word, okay? So in here, you can see we created a job and we submitted it. We need to get rid of this code from here down to the end of the code. And also we need to find the code which is for load. Here it is. As you can see, this is the code for load. I'm gonna delete it. Okay. Okay, and there are a few code between these two. So from here to here, I'm gonna delete the rest. So this code is for creating the job. Now I need to add a loop. For here, I would say for I in range 2 to 11, and then I'm gonna add one tab for each line. For each model, for each job, I need to add 100 Newton. In here, I would say plus 100 multiplied to I minus 1. The reason that I add I minus 1 is because we are starting from 2. So the next model, which is number 2, it's gonna put I 2. 2 minus 1 is 1. So minus 1 multiplied by 100 is gonna be 3600. I need to change the name here to plus stri. Also in here plus stri. So for each loop, it's gonna add the load, and also after that it's gonna create a job, and after that it's gonna submit the job. I think it's ready now. Now we can submit it. So we need to go to the run script, and I'm gonna select it. As you can see, it's creating the models. All are submitting. This is from 2 to 10. All of them are running together. As you can see, the models are starting to complete. In here, we can check the results. We go for this model, and then we see the stress. It is about 139 megapascal. The next one is 141. Next one is 144. I'm gonna go to the two last one, 151, and the last one is 151 something. So it's the last two are pretty much close together. So as you can see, we have right now, by adding load, we can see the result, so we can plot a diagram of it. We did our parametric study based on the increasing the load and seeing the maximum stress in part. And okay, thank you very much for watching this video. I hope you enjoyed this video. If you have any idea or if you have any question, please let us know so we can share, we can improve our videos, or we can help you with your question. Until the next video, bye.